Hi, my name is Massimo Banzi and I like to make things. And welcome to another Arduino tutorial video. Today we're going to learn how Arduino can control software running on your computer. So we're going to be using a very simple circuit that you can see here, where we're going to be reading the position of a potentiometer and sending that data over the USB connection into your computer, where a small program written in the processing language is going to be used to change the color of the Arduino logo depending on the position of the potentiometer. So how does this work? Well, if you notice, the Arduino has two chips. One main processor here, which is the one that executes the code that you program in the Arduino IDE, and this other smaller square chip that lets the Arduino processor communicate with the USB bus over to the computer. So we're going to be using, for this project, something that's called serial communication, because the Arduino will send data over to the computer 1 bit at a time at a certain speed that we will define in software. And then the square chip that you see here will convert that into USB data that travels over to the computer. We have used serial communication in the past in order to visualize the data that comes from the Arduino board within the Arduino IDE. There is a button on the Arduino IDE called Serial Monitor. If you press that, a small window opens up, and then you can see all the data that comes from the Arduino board visualized scrolling down the small window. And then there is a little menu at the bottom that says normally 9600, and that's, for example, the speed of communication used by the Arduino to send the data. So the Arduino speed of sending and the Arduino speed and the Arduino IDE speed of receiving have to be the same in order to sort of keep the data readable. So in this case, we're going to be doing more with the data that comes into the computer. Instead of just visualizing it on the screen, we're going to be using another software to capture that data and use it to do something and control the software from the Arduino. To do this, we're going to be using the processing language. Processing is that was a major inspiration and one of the bases for developing Arduino. And it's a great way to learn how to program. You can download the processing IDE for free from the processing.org website. After you download it, you should install it according to the instruction you find on the website, and you should go through a couple of tutorials like the overview tutorial. After that, you can load the processing code into the processing IDE, and you can load the Arduino code into the Arduino IDE, and then transfer the program onto the Arduino board. And after the code is loaded, you will see that the TX LED will start to blink, signaling that the Arduino is sending data. So you can open the serial monitor, see the data scroll on the screen. After you see that, the Arduino part of the work is done. You can close the serial monitor. Then you switch over to the processing IDE. You press the button to start the code on the processing IDE. That will read the data coming from the Arduino from the serial port, and then you will use the number to change the background color of the Arduino logo. Now, we should go through the code and see in detail how the two different applications work. Let's build the circuit first. So here, you can see that we have a potentiometer plugged into the breadboard, and we have one wire going from the potentiometer to the analog input 0 in order to read the value coming from the potentiometer. Then we have two wires connected to the potentiometer going to the plus and minus rail on the breadboard. And then we have a red and black wire going from those two rails to the 5 volt and ground signals on the breadboard. So when I change the position of the potentiometer, a corresponding voltage is coming out of this wire and going into the analog input 0, and that data gets converted into a number that gets sent down to the USB cable over to the computer and then to the processing code. We'll start with the Arduino code. So here, you see the code is very simple. In the setup function, we have a serial.begin command with 9600 as a parameter. So this opens up the serial communication between the Arduino and the computer at the speed of 9600 bits per second. Then, in the main loop, we read from the analog input 0 using analog read A0. The value that we read is between 0 and 1023, and we divide that by 4. This is because serial.write, which is the function that we are using to send the data over to the computer, only accepts bytes that have a value that goes between 0 and 255 as a maximum value. So by dividing the result of analog read by 4, we go from a value that goes between 0 and 1023 to a value that goes between 0 and 255. So serial write sends the data from the Arduino onto the cable over to the computer. After that, we have a delay of 33 milliseconds just to avoid overloading the serial communication with too much data that can actually create some problem on some slower computers. So once the data is reaching the computer, then we have to explore what the processing code is doing in order to read that data and visualize it. So switching over to the processing code, at the beginning we have this import statement that imports the library called processing.serial. This one is the twin library of our serial.begin, sort of a serial library on Arduino. There is a corresponding serial library in processing that we are using to open the communication and read the data from the board. Then we have an object called serial that defines the serial port we want to use to communicate with Arduino. And then we define a p-image object called logo that will contain the logo image that we want to tweak. Finally, we have an integer value called bgcolor that starts off as 0 that defines the color of the background. So let's look at the setup function. At the beginning, we use color mode HSBC to define that the colors that we're going to specify later are using this HSBC convention. And you can read more about this in the processing documentation. Then we use the load image function to load the logo.png file into the logo object. Then the size function defines that the size of the processing output window is going to be the same as the size of the Arduino logo. Then here, there's a tricky part. There is a println statement that will print the list of all the serial ports that are present on your computer. This is because we need to know the name of the serial port in order to open the correct one. Now, for a strange number of reasons, on Mac, the Arduino board port is always the first one in the list. So if you look at the code that we have here, my port is defined as a new serial object that picks the element 0 in the list of ports, so the first port in the list. So on Mac and Linux, this generally just works out of the box. While on Windows, we get a list of COM1, COM5, COM3, COM19. The actual COM ports that you get on your computer change depending on your computer, where the Arduino is plugged in, and a number of other factors. So you will have to use the output of serial.list and what you see at the bottom of the screen on processing to determine which one is the port that you need to use. And then you change in your code, you change the 0 here that I am highlighting with the number of the port from the list that corresponds to your Arduino. After you're done that, the processing code is configured in order to talk to the Arduino, and we can then look at what happens in the loop. In the loop, we start off by setting the background to white by doing background 255. That sort of cleans the window at the beginning of each frame. Then there is an if statement that says, if my port.available more than 0, this basically is used by processing to check if that particular serial port has data that has come in recently that can be processed. If available returns a number that's larger than 0, there is data available that we can read. So we say bg color, which is the variable that defines the color of the background, equal myPort.read. So you can see now that if by looking at the code side by side, on the Arduino side, we have serial.write that sends the data. And then on the processing side, we have myPort.read that read the same number into the bg color variable. After reading the value that comes from the Arduino into the bg color variable, we use println bgcolor to print the value contained inside bgcolor at the bottom of the processing IDE window. After that, we use this function called background, where we use the value of bgcolor to define the hue of the color that we're going to use behind the Arduino logo. And then finally, by saying image logo, 0, 0, we tell processing that we want to basically overlay the Arduino logo on top of everything else on the screen, starting from coordinate 0, 0, so the top left corner of the window. If I now run the processing code by pressing on the Run button, I get a small window. And you can see that at the moment, the color of the logo is light blue, and there is 128 being printed at the bottom of the processing IDE. If I move the potentiometer, you can see that each value corresponds to a color. So 0 is red here, then it becomes orange, then 71 represents green, for example, and then we get to blue, and then to purple, and back to red. So we have seen that we are able to capture the value of a sensor here on the Arduino board, convert that into a number that gets sent over the USB connection to the computer, and then there's a piece of software on the computer that can capture that number and use it to control something that happens on your computer. So now, this new thing that you learned today opens up a huge amount of possibility, because there are literally dozens of softwares on your computer that can actually read data from the serial port. So anything that can read data from the serial port can be then controlled with your Arduino and circuits as simple as this. I hope you enjoyed the tutorial. And remember, you have to build it, hack it, and share it, because Arduino is you.